So today we are going to start our introduction on electricity. First of all, there's two types of charges involved with electricity. There's positive charges, which means that an atom's going to lose electrons, and there's a negative charge, which means that an atom is going to gain electrons. So if you remember from last year, atoms are made up of three molecules. The nucleus in the middle is made up of the positively charged protons, shown in red, and the neutral neutrons, shown in white. Flying out around there are the negatively charged electrons. Those electrons, they can move or be transferred from one object to another. So if an object is going to lose electrons, it has more positive protons, giving it a positive charge. If it gains electrons from another object, it's going to have more negative electrons than it does positive protons, giving it a negative charge. For example, if you rub your hair with a balloon, the electrons are going to be transferred from your hair to the balloon. So what kind of charge would your hair have if those electrons from your hair were transferred to the balloon? It would have a positive charge because it lost some of those negative electrons. So what kind of charges would the balloon have if it gained those electrons from your hair? It would have a negative charge. And here's a picture of what would happen. A lot of you guys have probably done this or seen this done before. Your hair would then stick to the balloon. Since the positive and the negatives are going to be attracted to each other, that's why your hair is going to move towards the balloon and stick to it. So hopefully you watched some of the videos that I'd posted and asked you guys to watch. So what would happen if you rubbed a balloon on your shirt or a piece of PVC pipe on a cloth? Okay, electrons would be transferred and one atom would become positively charged while the other atom would become negatively charged. So let's look at something called electric force. All charged objects exert an electric force on each other. Okay, these forces can be either positive or negative depending on the charge. Okay, so the same charges are going to repel each other or push each other away, where different charges are going to attract each other, make things stick together, like in the previous example with the balloon in your hair. One atom was positively charged and one was negatively charged, and it caused them to want to stick together. So here's an illustration that can help you remember that those opposite charges attract, and either two positive charges or two negative charges, those same charges or like charges, are going to repel each other or push each other away. Okay, here's just another example that shows if you have two positively charged objects, they're going to push away from each other. And if you guys watched all three of the videos, you saw this happening in some of the videos. Okay, and the same thing, if you have two negative charges, they'll also push each other away. But if you have a positive and negative charge, two different charges, they're going to push towards each other, attract. Okay, so in one of the videos that you guys should have watched, why did the balloon stick to the wall? Okay, it stuck to the wall because the balloon had a positive charge and the wall had a negative charge. And so the opposites were attracted and it caused the balloon to stick to the wall. If you have a balloon at your house, you can try this. Just rub the balloon on your shirt and then gently stick it to a wall. And it should stay there. It can stay there for a really long time depending on how long it stays charged. Okay, so let's look at a little bit about electric fields. You may have noticed in some of the videos that the charged objects, like the piece of PVC pipe, it didn't have to be touching something else, yet it still exerted that electric force on another object. It still caused it to move towards it or move away from it. Okay, that's because electric charges, they can exert a force on each other at a distance, and that's called an electric field. Okay, so positive charges have a field that goes out, negative charges have a field that comes in. Okay, as you get closer to a charged object, the electric field becomes stronger. Okay, the electric field around a positive charge, again, points outward, while the electric field around a negative charge points inward. So when you combine these, this is kind of what those fields would look like. You can see with the positive and negative, the opposite charges, they're going to attract or pull towards each other. While with the two positive charges, they're going to repel and push away from each other. Okay, so in the video, we saw the piece of PVC pipe, and it caused that aluminum can to roll when that PVC pipe got close to it, even though it didn't touch. So why did that happen? Okay, that happened because of that electric field. It was exerting a force on that can, even though it wasn't touching it. If you have an empty aluminum can and a balloon, you can try this at home. You don't have to have a piece of PVC pipe. It will work with a charged balloon. Just rub the balloon on a cloth or on your shirt or even your hair, and this again will work with a balloon instead of a piece of PVC pipe. Okay, let's look at the one more thing called electric discharge. Okay, when you have two of the opposite electric fields and they're strong enough, that charge can actually jump through the air from one object to another. For example, if you've ever been shocked when you touch a person or a doorknob, that's what's happening. Okay, air currents can cause the bottom of a cloud to become negatively charged. And when the ground below becomes positively charged, lightning occurs. Two areas in the sky can also become positively and negatively charged, which can cause that electric discharge, which is lightning. So we've all seen, probably both of these, experienced static shock or seen lightning. Okay, charges can be transferred in different ways. There's three main ways, three methods by which charges can be transferred that helps to build up static electricity. The first one is through friction. Okay, charging by friction, it's when electrons are rubbed from one object to another. So if you put some socks on and scoot your feet across the carpet, like is shown in the illustration, it would cause your socks to become negatively charged. It would pick up those electrons by rubbing across the carpet. The next type of transfer is called conduction. Conduction would be when your foot, wearing those negatively charged socks, become negatively charged also, just because the electrons are transferred by direct contact. Your socks are touching your feet, and those electrons can automatically move into your foot or into your body. And the last type of transfer is called induction. Induction in this illustration is happening. You can see that there's electrons on the girl's fingertip, produce an electric field that repels negative charges. So it's going to push those negative charges in that doorknob away and attract the positive ones. And this is going to give that an unbalanced charge where it's positive on one side and negative on one side. In one of the videos you guys saw an electroscope that was built. An electroscope is used to detect the presence of a charge. Okay, so you usually have some sort of knob with a rubber stopper and a metal rod going down through there. In the video, I think they use like a paper clip with some metal leaves or foil on the bottom. And when you bring a negatively charged object near the top of the rod, then those electrons are going to travel through that rod and cause the pieces of foil or the metal leaves to repel each other. So you'll see those metal leaves move away or push away from each other. Same thing with a positive charge. If you bring an object that's not charged near it, then nothing will happen. Okay, so let's look at some insulators. and what that is. An insulator is any material that does not allow electrons to move freely through them, such as plastic. Plastic does not allow electrons to move through it very easily. Wood, glass, and rubber are also good insulators. They don't allow those electrons to be transferred. They don't lose or gain electrons easily, and so they're called insulators. Then we have something called conductors. Conductors are any material that allows electrons to move through them very easily. The best conductors are metals, such as gold, copper, and aluminum. So, is the human body a conductor or an insulator? And how do you know? If you watched the video, one of the videos, all three of the videos, one of the videos showed where it had several students and they were touching this little thing that would light up. And you can see that those electrons through that, anytime those students were touching in a complete circle, it would cause that light stick to light up.